Hi everyone, thanks for having me. As I was already introduced, my name is Simon de Haan. I'm the CTO and co-founder of a company called Turn. I have far too many ways of making coffee at home. I was very pleased and impressed. You guys set a high bar with your coffee gear here. This is quite something. I'm inspired. But yeah, so thanks for having me here. As I said, I'm the co-founder of a company called Turn. Now, I know Turn has a very specific meaning within the WebRTC world. I'm sorry to disappoint. Turn has nothing to do with Turn, as in the WebRTC specific technology. We're a for-profit social enterprise, and we develop and run a SaaS platform that helps organizations power life-improving conversations. And this is likely going to be one of the least technical, pretty much my bet's on it. This is the least technical talk at this conference. But I'm hoping to shed some light on how the technologies that you all are working on are actually improving people's lives in dramatic ways in the global south countries. And so as engineers, it's easy for us to focus on the details, as we should. I saw latency as a social contract somewhere posted. And these are really important things, but ultimately what matters is the experience that we're delivering to the people that use our services. And so I'd like to talk about the opportunities in making healthcare accessible in the global south using the technologies that you all know. So we fundamentally believe that a message or a conversation held at the right time can really dramatically change someone's life. It can be directional and a positive force for change. We work with social entrepreneurs, as I said. This is governments, nonprofits, for-profits, and we focus on global south countries, specifically in health, and that's in Latin America, Africa, and Asia Pacific. We have a really strong focus on healthcare because we believe that that's the biggest impact that we can have in people's lives in the coming years in that specific vertical. In 2024, we helped 200 organizations have 60 million conversations to improve the lives of 12 million people. 2025, we're working hard to double that. So if we're talking about healthcare, I pulled up some stats and focused a little bit on Africa alone. Now, sub-Saharan Africa has a 45.5 higher maternal death rate than Europe. So that means, if you're looking at the hard numbers, sub-Saharan Africa experiences 546 maternal deaths per 100,000 births, whereas Europe or higher income countries have it at 12. These are massive, stark differences between these regions and health outcomes, and many of these are entirely preventable. There's a projected shortage of 10 million healthcare workers by 2030 in sub-Saharan Africa. So right now, sub-Saharan Africa operates with only 1.8 physicians per 10,000 people, compared to Europe, which has 43 per 10,000 people. This directly translates to entirely preventable deaths and incredible suffering. On top of all that, the region carries 25% of the global disease burden with only 3% of the world's healthcare workers. Again, stark differences. Now, to make matters worse, free healthcare is still too expensive for most people. And I hear you thinking, how can free be too expensive? Turns out, if you have no money to spend, everything becomes more expensive. So we did some research on this into the cost of free healthcare. And so for many, a single visit to a healthcare facility can consume up to 30% of their monthly income. And this is just stuff like transport, getting there. 43% of the global population cannot walk to a health facility in 60 minutes. They're just too far from a health facility. Time spent in queues, waiting for healthcare at a public health facility there's a cost associated to that. People cannot work, and the lost wages often ends up being costing more than the actual health intervention or the medical costs. And then there's indirect costs: childcare, food, sometimes accommodation. All of this adds up. So while healthcare facilities are free, and these are great, and governments run them, and they should, there's still a massive cost for people in emerging markets to access this healthcare. So, see you all looking at me. We're at a tech conference. Why are you bumming me out with all these stats? I think it's important to be aware of these things, but at the same time, it inspires me. I think there's so much good that we can do as engineers to change this scenario, to change this and improve people's lives for the better. And so, a helpful lens for me to look at it is what is going to be inevitable by 2030. If we do absolutely nothing, How are things going to change anyway, regardless of what we do? And then how can we use that as a force multiplier for the work that we want to do and the positive change we want to be bringing? And so one of these things that I think is inevitable by 2030 is that AI compute will be a commodity. Costs of AI compute have dropped tenfold every year for the last couple of years, and I'm expecting that to continue. And so that means any service launched will have some level of AI compute available to them to improve that service in some kind of meaningful way. Phone and data connectivity will be available and affordable by 2030. I would argue that this is already the case in most countries. Everyone has a phone, certainly in the markets that we work in. Data coverage is available. I think India is leading ahead with pretty much data almost being free, certainly for low-end data services and chat services. And so not only does it mean that phone and data connectivity will be available, it also means that it will be the primary means within which people consume services or access services that relate to them, their work, their health, will be their phone, in the way that for us, the primary service may have been radio or computers, desktop early on, or laptops. For them, it's just their phone. That's it. That's the way they communicate with the world. The other thing that's inevitable, I think, is that WhatsApp is going to be the default telco. On the left here, we see a graph from an organization called Gapminder. And they break up the world in income distribution. And so the first column there is $0 to $2, people who live on $0 to $2 a day. The yellow dot at the bottom, at the top, so the yellow doll at the top represents 1 billion people. And their main means of accessing the world and the internet is still an old phone, possibly the ones that I'm showing my age, but the ones that we use to play Snake on, for example. The way they get water is from a well. The way their transport is walking, and the way they prepare their food is on an open fire. Now, there's not much that we can do in terms of like digital data things for that for that segment, but thankfully that segment is actually shrinking. The really interesting ones are the level 2s and 3s, and those are 3 billion and 2 billion. So that's from $2 to $8 a day, or $8 to $32 a day. And we added the pictures on top. The original image of this only has from here down. We added the images on top for the types of phones that people have in those areas. And so from here on, $2 a day, you have a data-capable phone, you have a low-end Android that's able to run tools like WhatsApp, and most likely, every phone that's shipped into the market that fits this category in many of these markets will have WhatsApp pre-installed anyway. And so WhatsApp is the default telco. And so whether we do something about this or not, no matter what we like about the parent organization of WhatsApp, this is going to be the case. And so all this together, I think, brings us to the conclusion that it's inevitable that all essential services will have a conversational interface to them. And what I mean by that is that people interact with the wider world through their phones. And so the services that they need to be exposed in a way that works on phones. And we believe that we'll be talking, voice services, chat services, that kind of stuff for the majority of the people. And so the opportunity here is that you can offer ultra-low-cost, expert personalized healthcare at scale. AI compute is available. Phone coverage is largely solved. WhatsApp is pre-installed on these systems, and the services that people will rely on to live their lives, to access their health, will have a conversational interface to them. And so delivering health via this medium, in our opinion, is inevitable. And so we're seeing signs of that actually happening with some of our customers. So Penda Health is a primary healthcare provider in Kenya. They serve over 600,000 patients a year with bookings and follow-ups and telehealth services via WhatsApp. That's right now 50,000 monthly users for a consult of $2. So if you're able to offer that at the location where they are or via WhatsApp, $2 ends up being a very interesting business model for these organizations while still being better and more affordable than the free option in public health sector. Pinky Promise offers an instant and affordable AI-powered digital clinic for women's sexual and reproductive health in India. This is a completely digital clinic, telehealth services, chat services, and it's from 15 minutes from symptoms to script at 99 rupees a consult, which is also about $1. Mom Connect is the South African Department of Health's National Maternal Health Service, registered 5 million mothers at the moment, provides age and stage-based information for mothers during their pregnancy up until the child is 4 years old at the cost of $20 per person per year. Extremely low-cost health services that build on these channels that we all know and work with. Kilkari launched about 2 months ago. They're now at 170,000 mothers. They're growing to 70 million in the next 5 years across 3 states in India. Again, these are services that provide essential information, and they're looking at adding calling services on top of this as well. Now, a lot of this, getting a little bit more into the technical bits, these systems are largely on our platform. They're powered by a DSL that we've written. It looks a lot like Elixir. It's not Elixir, but we use Elixir in the background. And so these are state machines. So you can see at the top, if a message is received, if it has any of those messages, then proceed, and then ask the first name, welcome to the Healthy Clinic, what's your first name? Great, what's your surname? And what is your date of birth? And then basically it just steps through. It's a state machine for these kinds of things. And so for chat-based services, the visual counterpart of this, the document that we were looking at earlier is generated by this tool, is that essentially you have a state machine. State machines are great, they're highly predictable, but when you expose humans to state machines, strange things happen because the state machine expects the other side to act like a reliable system. Humans are highly irrational and unreliable and do not act well as state machines. And so you end up in things where someone says, well, what's your name? And I'm going to say Simon de Haan, and then it's going to ask me, what's your surname? I was like, I just told you it's de Haan. But these systems are incapable of actually dealing with that in a really good way. So that brings us to more fluid voice conversations powered by AI. How do we go about that? And so our stack, I already mentioned it earlier, is Elixir-based. We've been working with Software Mansion on using Elixir WebRTC to expose WhatsApp calling. We've been working with WhatsApp since January on their calling offering. We've been working with OpenAI on their real-time LLMs. Both have WebRTC connections to them, and we're able to connect the WhatsApp calling to OpenAI services or to human services that are answered in the desktop tool, and power just life-improving conversations around people's health with that. We prefer, as much as possible, just off-the-shelf things. So we use Kubernetes clusters on AWS and GCP. And the thing that we had to add for this deployment was stun servers provided by Cloudflare. Again, these are just off-the-shelf things. Everything else for the calling functionality that we added is powered by Elixir WebRTC, and we have a pretty stock standard Phoenix application that does this. The WhatsApp API itself for calling, it just builds on the Meta Graph API. So if someone calls, we get a webhook that has the SDP in there, we answer it, we process it. There's some tricks that Meta has introduced to pre-accept the call so that the call answers quicker and that you avoid trimming of audio at the start of the call. And it works incredibly well. Meta has designed a very strict calling consent into it, so a business cannot just call anyone. So there's no robo-dialing with WhatsApp Business API. The end user has to give explicit consent that the organization is allowed to call them, and that's a time-limited consent. And within that window, the organization can call them. So the organization needs to send them a message and say, hey, can we call you? User needs to say yes. Organization has limited time to answer, and then the call can take place. Architecturally, Danny in the previous call already talked a little bit about supervision trees. We have, again, Elixir, for those who know Elixir. This is familiar stuff. The supervision trees here provide resilience. If a call comes in, we have a dynamic supervisor. It spawns a call router. It's a stateful process that's running for that call in our distributed environment. And those things spawn peer connections, one of them to WhatsApp for the WebRTC connection there, and the other one to OpenAI. Or if the human is answering it, it's a peer connection straight to the browser. So this is, on a high level, how the whole thing ties together. I added the screenshot again of that markdown document that we were looking at earlier, because for these fluid conversations, what we're actually doing, where previously this was compiled down to a state machine, we're now providing this as a markdown DSL straight to the LLM as context. And so the LLM actually knows what it's supposed to do without being very prescriptive about it. It's more like a guideline for health operator would or a phone operator would answer things in a call center. So what does this look like? Let's see if the video loads. So the interesting thing, while this sound is coming up, is the sound going? Yes. So look on the right as the data comes in.
To get started with your registration, may I please have your full name and surname?
Sure. My name is Simon and my surname is Haan. That's spelled D-E space capital H-A-A-N.
Thank you, Simon Haan. Next, could you please provide your South African national ID number?
Sure. That is 800-730-5289-180.
Thank you for providing your ID number. From this, I gather that your date of birth is July 30th, 1980, and your gender is male. Legislation has been successfully updated.
Okay, so on the right you see that it says, oh, that went away. On the right you'll see that my information is automatically captured and populated into my profile. And what this means, and this may feel like such a trivial example, in reality, in these systems that we work in, these health clinics and government clinics, 80% of registrations are considered new because the registration process is paper-based. All of that information is lost. So if someone registers with a chronic condition and need to come back again in a month's time, the current systems allow for zero follow-up on any of that, leading to terrible health outcomes. The fact that we can do registrations now, capture that all information with a 30-second voice call, register them in the system, in the national health system, prevents a whole bunch of just preventable health conditions for those people going forward. Is there anything? Yeah, so this particular one, in the production version that we have now, also has the live transcriptions in there, which is really important for audits. This one just didn't really show it. So how are we doing this? Now here's an example where the LLM is taking the markdown that we've provided and using it as context for the real-time conversation. And so you'll see it's a far more fluid experience because it'll read the markdown description of what it should do, but not follow it to the letter. Here we go.
That's Simon.
Thanks, Simon. And your surname?
Haan.
Oh.
Got it. Simon Haan. And what is your date of birth?
1st of January, 1985.
Thanks. And what is the reason for your appointment? Briefly describe your symptoms or request.
I have a persistent cough.
Thanks, Simon. I have your details. Name, Simon Haan. Date of birth, 1st of January, 1985. Reason, persistent cough. We will contact you soon to confirm the appointment.
Great, thank you.
So the fact that we can do this is mind-blowing. The impact this has on the health system is incredible. Just the fact that we can just say, well, design a registration journey, serve it over WhatsApp, and make it available to pretty much everyone who is in the level 1 or level 2 or 3 that we were looking at. It's an ability to scale healthcare worldwide in a way that was previously completely unimaginable, and it builds on the technologies that we're all discussing here, WebRTC. And so the idea of offering ultra-low healthcare is actually becoming a reality with the technologies that we have available to it. WhatsApp has 4 billion users. The majority of them are in the global south. Costs of AI are dropping. Again, as I said before, WebRTC provides a really fantastic means to connect these people to healthcare. And frankly, there are more than 4 billion people worldwide in need of health, and the technologies at hand really give us an incredible opportunity to move the needle in significant ways there. And so my goal is, I'm really hoping, I know we have, in the startup world, we have a definition of a unicorn. You know, so a startup that actually got to $1 billion valuation. I think those things are fine. What really motivates me is the idea of improving 1 billion lives towards better health. And I think it's entirely possible with the skills and the technologies that we have available to us today. So this is it. This is my presentation. Thanks all for the hard work that you all are doing. Thanks Software Mansion for hosting and making the software open source and available to us and working with us on getting it deployed. I'm finding this incredibly meaningful work. If you have more questions about this, let me know. I'll be around. Thanks.
Thank you very much, Simon. Question time. Over there.
So thank you for the talk. It was very inspiring. So I'm also working in a field of like voice AI, and I had this very bad experience that everything works very good in English, especially like speech to text part.
Yeah.
But then when you switch the language, something like let's say less rare.
Yeah.
Even my language, which is Hungarian.
Yeah.
And I imagine it's the same thing in the global south where there are local languages, local dialects. Isn't that a very hard problem to solve?
Yeah, yeah. It's an incredibly hard problem. We are not LLM model builders, but I expect this to be a solved problem in the next 5 years. And I'm expecting, if it's not completely solved, languages are going to converge, right? At some point we had SMS speak. It wasn't perfect, but it worked, right? And so people are able to converge on a language that works in both directions. We're probably going to see, like the first time I heard these LLMs talk in Dutch, which is another language I speak, they spoke with a really thick American accent, but I could understand them, right? And so the access element is more important than it being perfect. Many countries that we work in, there's actually code switching. English is one of the main used languages in Kenya and Tanzania, for example. So it's not perfect, but it's better than the healthcare that's available to them today. So the question is, are these good enough to start being deployed? There are many, many concerns around using LLMs around health, and we should completely look at those problems and tackle them head on. At the same time, I feel like these LLMs are so important, it'd be irresponsible for us not to use them for these kinds of applications either, or at least not explore using them. Does that answer your question? Okay.
Rob has a question over there, I see.
Thanks again, fantastic tool, probably the best use of LLM voice I've seen. I have 2 questions, so I'll go with the first one and then Seed and maybe come back to the second one. So first question, in your demo, you did a couple of bits of information capture.
Yeah.
You did the name and the social security account or whatever.
Yeah,
I presume you're using OpenAI real time, so your only way of extracting that is through tools calls, I guess, is what you're doing there.
Yeah.
How are you finding the accuracy of that kind of information capture? Is it adequate for this kind of application?
We still do validation on those things. So the tool call will say, hey, this is great or this isn't great. So for example, that national ID is a bogus one, but it is valid. There is validation and what's the validation that you can use on like strings of numbers with the last digit? Something like that, yeah. And so we do those checks on the back end when the function is called and the report back say, hey, this was wrong. And then the LLM will say, actually, try again, that was wrong. So there is some amount of validation that we can do. We do not trust whatever the LLM gives us blindly. LLMs are surprisingly bad at reciting numbers for some reason.
Yeah, I mean, it's not just that, it's also things like the name. I noticed you took trouble to spell out your name, but often the accuracy, even when you go to those lengths, is quite hard.
So many people will have trouble spelling their own name when having to use English. So there's that already. And then there's other things that come in. So if we know a fair amount about the person who's calling, potentially, right? So we can see what their phone number is, and so we can deduce maybe what their preferred language is, and we can seed the model with that information, and then it's able to navigate to spelling, right? A couple of months ago, it kept spelling my colleague, Ricardo, his last name, Gonçalves, he's Portuguese, kept spelling that wrong. The other day he tried it again, it was perfect, and he said he pronounced his name better than his own parents did. So these things are constantly improving.
Fantastic, thanks. I've got another question, but are there other questions? I don't want to...
So Will had a question.
Well, just finish there.
Oh.
You sure? Okay, so the economic environment you're operating in, you know, you're talking about $1 an hour for conversation time. Are you getting any subsidy from partners like OpenAI for this? Because surely getting your token cost down to that level doesn't work, right?
Not yet. Not yet. But it has to work. And we're working closely with OpenAI on these things. We run health accelerator programs with various organizations. Right now we're running one with 10 organizations in partnership with OpenAI to see what are the use cases, what are the cost models that work for this scenario. And so OpenAI is very heavily involved in that. Ultimately, these things should be self-sustaining. The whole international development health sector funding is dead, pretty much, in the last 6 months because of all sorts of political shifts. And so it is incredibly important that these systems are at least revenue neutral, not running a loss.
Fantastic, thank you.
Simon.
Yes.
Lekker talk, thank you.
Lekker.
A question about the authentication, right? You gave an SA number and it updated your medical records purely based on something you said into the phone. So how do you address the question at scale of authentication that you know this is the person you're talking to? Are voice fingerprints used? And if so, how do you set them? Where do you get the trust in the first place to generate the fingerprint and then attach it to that user?
Yeah. We don't at the moment, right? We use the phone number and we connect with medical records where possible to verify the information that we're getting. And then there's a bunch of vetting processes that need to happen there. Right now, the industry is not there yet for that, at least to my knowledge, of building that trust well enough. I think that's something we're going to need to learn how to do well. And I think the harder part really is helping people understand on like the receiving side. If someone's in a village with a WhatsApp on their phone and they're calling and how do we build a process that actually meets them where they are, well, and helps them understand the importance of that trust. So like the human social element of that, I think is probably going to be one of the more difficult ones to introduce over the technical one. If anyone here has any great ideas on how to go about that, come find me.
Thank you.
Cool.
All right, let's thank Simon again for the talk and the work he's doing.
Thank you.